And thanks everybody for joining us today for this tutorial. We're really excited to be here. My name is Joe Stubbs. I lead the Cloud and Interactive Computing group at the Texas Advanced Computing Center at the University of Texas at Austin, and I'm also the PI of the TAPIS project. And we're excited today to be talking to you about how you can use TAPIS for CI/CD workflows involving high performance codes. And I see that there's already a question in the chat. What is CI/CD? This is great. CI/CD stands for continuous integration, continuous delivery. But we're going to be talking a lot about what that is, and in particular, what are some of the specific challenges to developing CI/CD workflows for high performance codes, right? So I'm joined by several members of the TAPIS project team, Nathan Freeman, Steve Black, and Anagha Jamthe. We are all staff at the Texas Advanced Computing Center. And we're excited to talk to you today about TAPIS. As Claire said, please, we'd love for this to be interactive. So, if you have questions, feel free to use the chat. Or, just raise your hand if you have a question and you want to interject something. We're happy for you to do that at any time. So we'll start off with just a few slides here to kind of kick off the tutorial, but a lot of it will be interactive. So to start with, I want to just kind of mention, cover some of the basic outcomes that we're hoping you'll come away with from the tutorial. So first, kind of to talk about the challenges associated with computational research in general, right? To have you come away with a basic understanding of things like portability, reproducibility that come up in computational research, and also collaboration, right? Sharing, disseminating results. So we're going to talk about some of the tools, particularly in TAPIS, but with other technologies that we have available for addressing some of these challenges. And to that end, we'll introduce TAPIS API platform and show you how you can incorporate it into some of your own research computing tasks. And again, in particular, we'll focus a little bit on CI/CD, that's a typo there, CI/CD workflows involving HPC codes. But in general, the things that we're talking about today, are applicable to a large class of research computing tasks, not just CI/CD. We'll be talking about container technology a bit, Docker containers and Singularity containers where it makes sense to use each of those. And interactive computing like Jupyter Notebooks for scientific computing. So I'll start off by getting some basic background and motivation on TAPIS. But here is a link to the course material. So everything is on GitHub. Everything we're going to be talking about today is hosted on GitHub. And so that's a link to the course materials hosted there. And I can see the chat, but I'm not sure I can see if there are, hands raised. So, Anagha or Steve, Nathan, let me know if you see somebody. Feel free to interrupt if you see that somebody has asked a question.
Will do.
Thanks. All right. So, kind of just to set the stage here a little bit. If you look around the national cyber infrastructure ecosystem, what you see is really a wide range of powerful set of tools and capabilities for research computing, right? It's robust, it's very robust, but it's also heterogeneous. There's a lot of different kinds of technologies, a lot of different specialized systems, spanning a number of different areas, right? High performance computing, of course, but also cloud and high throughput computing, big data, data science, visualization, and experimental architectures. And we just see all of this and we feel like it's a lot for researchers that are really trying to do research in a specific field like biology to try to master, on top of the actual research that they're trying to do. This slide just depicts a little snapshot of what we have just at TAC, where we have over 12 production systems. And you can see here most of the architectures and the computing models and the paradigms from the previous slide are covered here. So again, it's just a lot, for a computational scientist to try to master on top of their own domain. Additionally, if you have a sort of distributed computational research problem, then you have a number of additional challenges that get introduced, right? Oftentimes, distributed computational research involves this multi-stage endeavor where you start off with needing to get at raw data, which might be generated by instruments or sensors out in the field, right? These could be things like sequencers or shake tables, telescopes. So you have to get at the raw data. You often then have to perform some kind of pre-processing step. And this, again, could be a wide range of different kinds of things, including some basic quality assurance stuff, more complicated extract, transform, load scripts, or even, some machine learning to pre-process the data. And then you might pass to a third phase where you're doing some kind of model simulation, right? And this, most traditionally involves technologies like OpenMP and MPI, but also more recently CUDA, and other kinds of technologies for machine learning. So, this model simulation often takes place, in the high performance supercomputing clusters, but is yet a third phase. And then finally, assuming that things went well and you have some results of interest, there's the issue of dissemination, right? Sharing results in a way that allows users to learn from them, to reproduce them, right? And there's different levels even to sharing, right? Typically, you start off by sharing privately with a set of colleagues, a set of collaborators, before publishing and then ultimately disseminating those results, to the general community. So this is just a lot. Again, there's a lot of technologies and techniques that are involved in actually mastering a pipeline like this. And this is essentially why we created TAPIS, to help you with each and every one of these aspects. So what is TAPIS? So TAPIS, in brief, it's an NSF-funded web-based computing framework to support computational research, really in any domain. So we're a domain-agnostic framework. And the basic idea is that we want to enable you to leverage this ecosystem, this cyber infrastructure ecosystem of computing and storage resources across institutions, right? And across boundaries, other kinds of boundaries. So from the edge to the data center and back. To be a little bit more precise, TAPIS is a cloud-based hosted set of RESTful APIs. And if you don't know what RESTful is, that's okay. We'll say a little bit about that during the tutorial today. But these are HTTP APIs. So essentially, the same protocol that you use when you're using a browser to interact with a website, that's how you interact with TAPIS. But they're designed in such a way to be friendly for consuming within a programming language. And to that end, we have a sort of an ecosystem of tools together with the APIs themselves that include things like programming languages, software development kits, right? And we have SDKs in Python and Java and JavaScript. We also have an official command line interface. If you prefer working with the command line, a lot of what TAPIS does is make it so you don't have to work in the command line with these computational resources. But in fact, there's advantages even if you like the command line to using TAPIS, because it gives you one API, one interface to all of the computational resources that you have to interact with. And again, the main motivation for TAPIS, the main objective, is to allow you to do data management and code execution on these resources, right? So data management, code execution, these are kind of the bread and butter of TAPIS and the ultimate goals of what we're trying to help you do. So these are kind of 3 higher level objectives to Tapas, what we're trying to enable for you, the user, when you use Tapas. Firstly, and probably most importantly, this programmable access to these resources, right? If you've ever used the command line on a login node, you know that it's lacking in the aspect that it is difficult to program against, right? If you want to automate a workflow that is going to involve interacting with a login node to submit a job, you know that using SSH and the login node and the command line is challenging, right? So we want to give you a higher level API that you can use in your own code, in your own programs and other kinds of scripts to automate the interaction with these resources. And it's not just login nodes on HPC systems, it's also edge devices, cloud resources, etc. So first and foremost, programmable access to these resources. But secondly, reproducibility. So any action that you take in Tapas, whether that is moving data between 2 storage locations, executing code for sure on an executable system, and so forth, any action you take is recorded. And we record as much information about the action as possible, right? So we include all the inputs that were used and the parameters that were set, any outputs that were created as a part of a run, for instance. We record that and we make it available to you so that you can see it and help with the rerunning of analyses after the fact. And then finally, this collaboration aspect, right? So we have a fine-grained permissions model around all of our resources, along all of our APIs, that allows you to share your data, your applications, the outputs from your executions, share them, again, privately with individual users and also publicly with entire communities of users so that you can collaborate, both meaningfully and securely. And and this is all running in the cloud, right, as a web app would, so that there's not a lot of software that you have to install. You just interact with it the same way you would a web server. So who is using Tapas? We really have garnered quite a broad adoption at this point. We have projects that are funded by NSF, NIH, DARPA, NASA, using Tapas. We have a lot of science gateways. Of course, we're at the Gateways conference here, so a lot of web applications, science gateway web applications are built with Tapas, but also, we're part of major institutes like the Icicle NSF AI Institute, which is being built with Tapas, and we also integrate with a number of centers and other organizations. So, we really do have a broad adoption, a broad community of users and actually contributors to Tapas. So I don't want to at all give the impression that this is a TAC-specific project. The University of Hawaii in particular is a co-organization on the original Tapas award, but we've had additional awards with a bunch of different universities and other kinds of institutions who have been contributing to Tapas. And here on just these slides, these next couple of slides, I'm just depicting, screenshots of a bunch of different science gateways that are built with Tapas. And you can see that it really is a large number of domains of science and other kinds of engineering that are using Tapas. So let me get in a little bit of details about the actual APIs that are in Tapas. We'll of course go into a lot more detail and hands-on in the rest of the tutorial, but I just want to kind of cast a high-level overview for you of what all is there. So we're actually on the 3rd version of Tapas, but we still have some people using V2, and some people were familiar with version 2 of Tapas. Will remember that we kind of had these primary capabilities there in V2 are what we call our 4 core services: systems, files, apps, and jobs. And these are the APIs that you use to essentially manage data and execute code on HPC and cloud systems. So these are kind of our core 4 services. But we also have a metadata service that we had in V2, which allows you to manage large collections of documents and other kinds of project metadata. We had a functions as a service that ran, in our internal cloud, so the internal Tapas cloud. So these were kind of, you could think of as like small little containerized bits of functionality. And then we have a complete OAuth 2 and OpenID Connect compliant authentication module. So that was all in V2, which actually dates back to 2014, is the initial development of V2. And then in 2021, in September 21, we went into production with V3. So we've been in production with V3 for a couple of years now. And really, V3 essentially extended a lot of the capabilities in V2. So essentially, all of the capabilities that were in V2 came over in V3. We did redesign some of the interfaces, but systems, apps, files, and jobs are still there. The functions as a service, metadata, the authentication module, all that is still in V3. But we added sort of some new capabilities. So firstly, we added first-class support for containers. In V2, you could execute containers, but you had to kind of write some glue code, essentially, to make that happen. In V3, a lot of that is much easier, and we'll see some of that later today. We have a new endpoint. We're not going to be able to talk about it today, but we've done tutorials on it in the past that allows users to process sensor data in real time from edge devices. We call it the Streams API. We have a new approach to doing authorization and secrets management, which is decentralized. We call it the security kernel. And it allows people to deploy components of Tapas on-premise in their own data center if they so choose, and manage the secrets and authorization data on-premise, so that you can, essentially use Tapas at your institution without, having to run the entire Tapas installation. And we can talk about that if there's interest in more detail later. We have a new scalable sort of relational database as a service, PG REST. And then workflows for automating, scientific workflows that involve multiple tasks. And of course, that's what we're going to be spending a lot of time talking about today. But I want to say just a few more words on these core 4 APIs, the systems, files, apps, and jobs APIs. These really are somehow core to the Tapas platform and what you want to do when you're interacting with Tapas. So starting from left to right with the systems API, this is almost the kind of most foundational service in Tapas. This is where you register the actual storage and computing systems, the servers, the various pieces of cyber infrastructure that you want Tapas to interact with on your behalf. So this could be a high-performance computing cluster like Frontera. This could be a VM running in Amazon, or a lab server, running at your institution. But it's important to understand that, Tapas itself is running in the cloud. It's not getting installed on Stampede 2 or Frontera or your Amazon VM, right? It's not actually running any Tapas software on those machines. Instead, it's interacting with them over the network, some kind of network protocol like SSH, or S3, HTTP in the case of an S3 bucket, right? It's using the native protocol of the storage resource. But you tell Tapas by registering the system how you want Tapas to interact with that resource. So you kind of use the system service once, or a handful of times to register these resources. And once you've done that, you're kind of done. Using the system service. You can then use the files service to actually move data in and out of the systems that you have registered. right? So everything kind of builds on the system service, but files provides you not only this kind of synchronous management commands, move, copy, rename, but also asynchronous transfers between two different systems. And it can handle protocol negotiation in the sense that if one of them is a SFTP server and the other is an S3 bucket, it can do a transfer between those. Then we have the app service, and this is where you actually register the executable code that you want Tapas to run on your behalf. And in Tapas v3, we have this first class support for applications defined using containers. And so that's what we'll be talking about today, using Docker and Singularity on HPC systems for registering applications that are going to run there. And then finally, once you have systems and apps registered, we have our jobs endpoint. And this is where you actually invoke applications to run on systems that you have registered. So you might have registered an application, OpenSeas, and you might invoke it on the Frontera system by submitting a job. And of course, you can submit multiple jobs to run the same application with different configurations or on different systems, etc. And again, all of this, while it's happening, Tapas is capturing information, metadata about the events and the processing that's taking place in the workflow. All right, so with that, I think I'm going to end because I think, Nathan, you're going to start off by talking about workflows, right?
That's correct.
Yeah, you want to share your screen?
Yes, sir.
All right, I'll stop sharing.
There you go. All right. Hello, everybody. My name is Nathan Freeman, and I am a software engineer in the CIC group at TAC and one of the developers of Tapas Workflows. So Tapas Workflows is an API and workflow engine for constructing and running research computing workflows within the Tapas ecosystem. Tapas Workflows was originally designed to provide CI/CD within the Tapas ecosystem, and we're going to get more into what CI/CD is in just a sec. But the Workflows has since been extended to serve as a general purpose workflow engine to run your scientific workflows on HPC infrastructure. So in Tapas Workflows, there are 4 primary components or concepts that you need to understand before you start constructing workflows. And the first is a pipeline, which is a collection of tasks and an execution profile that controls how the workflow engine processes these tasks. The second is the task, which is a description of the work to be performed in each step of the workflow, as well as a list of dependencies that needs to be satisfied in order for that task to run. Excuse me. A pipeline and its tasks are modeled as a DAG, a directed acyclic graph. And in this graph, the tasks are nodes, and the edges between these nodes represent the dependencies between the tasks. And all the tasks that do not have dependencies are the first to be executed. The third concept we have in Tapas Workflows is the group. And the group is a set of users that all have access to some collection of workflow resources. And the final concept is the archive, which represent permanent storage sources for workflow results. By default, the workflow engine is the results that are produced during a pipeline run that are produced by task executions are deleted after the run is complete. So if you want to persist your results, you have to specify an archive, and this archive could be an HPC system or an S3 bucket. So as far as the kind of work that can be performed using Tapas Workflows, we have a set of tasks, 6 basic task types that you can use to perform specific work. So the first one, which is one that we're going to be using today, is the image build task, and this gives users the ability to build both Docker and Singularity images from source code, and then push that image up to some container registry like Docker Hub. Next, we have the function type task, and this enables users to run arbitrary code in the language and runtime environment of their choice. There's a TAPIS job task, which is another one that we're going to be looking at today, which enables users to run jobs on HPC systems using the TAPIS jobs API. And a few others. We have the TAPIS actor task, which integrates with Abaco, that functions as a service that Joe mentioned earlier, via the TAPIS actors API. There's application task, which enables users to run containerized applications. And then the request task, which is used for sending and fetching data to and from external APIs. Okay, so on to what CI/CD is. So CI/CD is continuous integration and continuous delivery, sometimes continuous deployment. And so it's essentially it's a software development workflow for building and testing your software. The general workflow looks like this. First, you're gonna write and push code to source control, and then you want to make sure that code runs correctly. So you're going to run your unit tests and your integration tests. And then once those pass, you want to build your container image. And this could be Docker or Singularity. And then once this image is built, you want to test that it is functional, that it's going to run in the environment for which it is meant to run. So you run your functional test, and then once all of those pass, then you push it up to an image repository, and the very last part of that is going to be deploying your application to the environment that you want to run it in. So CI/CD for HPC, it's pretty much the exact same process. The only difference is that in order to run and properly test your HPC codes, or the image containing your HPC codes, you may need to run it on high performance computing resources, right? Like you may be using MPI, you may be using a batch scheduler, and all this is like integrated in your code. And that's kind of a little bit difficult to do, just running it on VMs or what have you. So we've created TAPIS workflows to make CI/CD easy. This whole image building process, pushing up to Docker Hub, and then testing that image on the HPC resources. TAPIS workflows makes that a lot simpler. So on to how we can use TAPIS. So of course, since these are RESTful APIs, you can always hit it from the command line with curl. That is the most difficult and time-consuming way, in my opinion, to use any API. So the next best thing is the command line interface. So all the APIs in the TAPIS framework, they have an open API spec, which allows their definitions, their endpoints, and their resources to be read and consumed by something programmatically. Like so the SDK, it uses that exact same open API spec to generate all these endpoints and operations that you want to hit to consume or mutate your resources in TAPIS. And the command line interface is something that just wraps this tappy pie and makes it a lot easier than using curl to access these resources. So you would say something like, in this example, TAPIS systems. So we're hitting the systems API, and then we're hitting the get system operation. And then you pass in a system ID, and then it's going to return all of the data for that particular system. There's also an interactive version with the TAPIS command line interface. So all you have to type is TAPIS, and then it'll prompt you and show you all the APIs that are available: systems, apps, jobs, workflows, streams, etc. And then once you select in the CLI from the dropdown some API, it'll show you all the operations that you can perform on that API. So for somebody that maybe doesn't work with Tapas a lot, or can't be bothered to learn every single operation like myself, the interactive version is a really handy way to go. And back to the TappyPy, which is the Python SDK that I mentioned before. This is if you want to, write into your applications, programmatically access your Tapas resources. And then, of course, there's web applications, science gateways, such as Tapas UI. Tapas UI is it's a serverless web interface for interacting with the Tapas APIs. So we already talked a bit about the Tapas v3 CLI, but a couple things, a bit of additional information. I'd already talked about the manual and interactive modes, so you can use it just as any normal CLI and type out the commands with the flags to perform the actions that you want, or you can use the interactive mode. There's also multi-profile support. So it's because Tapas is a multi-tenant system, quite often users will be working in multiple different tenants, and it becomes quite complicated to have to log out and log back in to access resources in different tenants. So this multi-profile support allows you to authenticate with Tapas and multiple different tenants and switch between those profiles with ease. It also has configurable displays. So if you prefer something like a table view, for example, which is the default display for results, you can have that. You can also just look at the raw response from the API call. You can format it in JSON and also display the JSON, as well as send the result of that API call through the CLI to some file so that you can use it later. It's also extensible. So if you have a particular workflow that you like in within the CLI, say you use a lot of the same commands over and over again, and you want to turn that into a single command, you can write your own package in the Tapas v3 CLI. And the architecture of the CLI is model view controller architecture. So essentially, you would create your own package, your own directory within the controllers, and then you would write your controller, and that controller's name would be the command that would be invoked, and then all the methods on that controller will be the actions. So you can easily just string together a bunch of commands. It does require a little bit of Python knowledge, but you can extend the CLI for your own workflows. And it's easy to update. As updates come through, you can simply say Tapas update, and then it's going to pull in all the changes for the most recent version. And we talked a little bit about Tapas UI as well, a little bit more detail. It is a serverless web interface for the Tapas APIs. There's also an official Tapas UI as part of the Tapas deployment, and this enables users to access all resources in all tenants. There is a supporting library called Tapas TypeScript. So this Tapas TypeScript they're essentially type bindings to all of the objects in the Open API spec. And this is also something that if a user wanted to write their own web interface to consume the Tapas APIs, they could use this Tapas TypeScript library to provide all of the type bindings so that you know exactly what data is required for the operation that you want to perform. As I mentioned, this is also is a static application. So this can be deployed on GitHub pages, for example. There's no backend necessary. It interfaces directly with the Tapas APIs. Yeah, so if you wanted to deploy your own Tapas UI, for example, you would fork the repo, and you would change some configurations related to the tenancy. So it would be like the base URL. So for the Tapas base URL, it's https tapas tac.tapas.io. That's the TAC tenant in the main Tapas deployment here at TAC. But if you wanted to use a different tenant, you would say the first part of that URL would be the tenant you want to access. And this is just in a little config file in the main repository. And then you just deploy it on GitHub Pages. And then now you're accessing all of your own resources in your own tenant for free. GitHub Pages is free. So it's a really nice way to stand up a UI. Okay, so that's it, I believe, for our slides. I think we're going to get into the hands-on portion of the presentation. So
Well, Nathan, sorry to interrupt. There is a
sure.
question in the chat.
Okay.
So, are there any reasons to use MS TypeScript instead of JavaScript? Is the question.
So yes. So we like JavaScript and TypeScript. TypeScript is just a variant of JavaScript, but it is a statically typed version of JavaScript. So when you build an application using TypeScript versus JavaScript, what you're going to get out of the box with the language itself is type safety. So with JavaScript, you can just deploy an application, and if you haven't put in all the proper validation for all of your objects, your application is very likely to explode at runtime. There's going to be problems. But TypeScript has this really nice compile process that you have to do beforehand, and it handles all of the validation, ensuring that all of your objects have the exact properties that are specified and the types that they have specified. So out of the box, you're just getting far more robustness than you would with a normal JavaScript application. It's a little bit more difficult to learn, as any strongly typed language is, but the amount of code that you have to write in TypeScript versus JavaScript to get the exact same amount of type safety, is far less. So that's one of the reasons why we use TypeScript. Thank you for the question. All right.
Thanks,
Um,
Nathan. We
should I
can take
hand it off to you?
any Tapas questions. If anybody has any more Tapas questions or workflows related, and then we can move on to the next part. Okay. You can unmute yourself and ask questions if you have any on Tapas. Otherwise, we can move ahead. I guess not. I think that's fine. We can take questions later when people have them. So, does everybody have link to the short link to the course? Because you will need that. And then the another part is you'll need training accounts. So let me share the training accounts link, and then we can begin with the systems presentation with Steve. So make sure you have access to this Google Doc here and try to pick any training account that you like. Maybe just add your name and organization name in front of it, so others won't use that. And the short link for course, again, I'm going to post it again. You're going to need those two things. Okay, can people check if they have access to these links? Okay, I see people choosing the accounts. That's great. We'll give like 2-3 minutes for people to choose accounts and then we'll move ahead. So until then, Steve, do you want me to share screen for the system slides and then we can take it from there? Or
Yeah, or well, should we start with getting the credential? I don't know that we have slides for that. I guess we'll just maybe go through the first part of the notebook.
yeah, that's fine too.
Yeah, and then
Okay, so
Yeah,
let me share my screen and show them how to get to the collab and notebook.
yeah, so basically, shall I go and start, Anagha? I can kind of kick things off.
Yeah, sure.
Yeah. So hello everyone, my name's Steve Black. Welcome and thanks for sticking with us. We're about to get to the hands-on part. Hopefully it'll be a little more interactive. And sometimes more problems with this part because we run into Jupyter Notebook basically to invoke TAPPY to do all the TAPPIS operations and try things out. So so the first thing to do is to actually get this notebook up and running. And then like with a lot of frameworks or systems, next thing to do is to log in, get authorized, authenticated and authorized. So, with that said, then sometimes that's actually can be one of the trickiest parts to get that all set up and logged in. So
Yeah.
what we'll do is start off with that.
Yeah. Thanks, Steve. So when you open the course link, you will find Introduction to Jupyter tab on the left. Make sure to click that. And from there, you'll find a direct link to the Google Colab. You can just open that in a new tab, and with your Google account, just log into that with any of the Google account that you might have. And the next thing, what we're going to do is we're going to download this notebook again on the same page where we have this Introduction to Jupyter. Download it, and we're going to open that from Google Colab. So once you log in Google Colab, you would get something, some welcome thing like screen. In there, you can just upload a notebook from your browser here, Finder. And then you should see something like this. So basically the steps are, first thing, you just go to this Intro to Jupyter tab, open the Google Colab in a new tab, log in with your Google account, download the notebook, and then open it in Google Colab. And once you're done with this step, maybe just give us a thumbs up or something so we'll know to proceed. And somebody who is monitoring chat, let me know because I cannot see if people are able to follow this step.
Yeah, nothing in the chat so far, Anagha, but I'll monitor.
Sure.
Yeah, if anybody is able to open it, maybe post in the chat that you have been able to do it successfully, so we have a sense of how far people are along.
See, it looks like I was just able to get the notebook opened. I joined a little late. The credentials that you shared in the spreadsheet, do we use those to log into are we authenticating with something?
Yeah, we will use that later and we'll show you exactly where and which ones to use. For logging into Colab, you can just use your Google accounts if you have.
Yeah, correct. Yeah, that's what I did.
Yeah.
But, okay, so the credentials in there.
Sure. Yeah,
it
yeah.
sounds like those are for
We'll
later.
tell you like how to
All right.
add those to the notebook.
Okay, thank you.
Okay, awesome. Anybody else having any issues uploading the notebook? Are we good to proceed?
Yeah, I see one thumbs up. So we have at least two people I think who are probably good to go.
Yeah.
And actually, how do you do the thumbs up thing again in Zoom?
I think reaction.
Just click, yeah, you just click on reactions, right? There we go. Thanks, Nathan.
Okay, I think this setting up is a little bit tricky, but I think once we are through that, everything will be just quick. So
Yeah,
we,
once you get authenticated and get your token, which you won't have to worry about recording or anything, it's all sort of documented, embedded in the notebook. It generally goes smoothly pretty quickly after that.
sure, yeah. So I think the first step we're gonna do is to install the TappyPy. So Python SDK to interact with all the Tappy services. So some of you might see error in the first go. So the work around it is like just click it again and it will go well the next time.
Yeah, if anyone have any questions about Jupyter Notebook and how to execute cells and that kind of thing,
Oh yeah.
just go ahead and interrupt. And I think that one error I see all the time, but it
Yeah.
doesn't seem to have an impact. I'm not sure what's going on with that, but it
So I
seems to
think
work.
if you see something like this with your notebook, just the workaround is just run it again, and I think that kind of fixes things. Yeah. So it might take few seconds for you to get TappyPy installed. So Steve, do you want to talk about tokens in general? And then we can tell them which
Sure.
IDs.
Yeah, so in this first section, basically we're just entering the basic username information and the URL that TappyPy is going to use for contacting Tappis. One thing I don't think we talked about much, just one basic concept, and like many cloud services, is the tenant. You know, each user is in its own tenant, and that's just sort of a way to separate different groups, different companies, different organizations for research projects. So everything's isolated by tenant. So here we'll be in the training tenant, which is hard coded in the notebook. And then we have the same base for the username, but everyone will enter a username, which you can just copy paste from that shared Google Doc. It all starts with gateways 23-training and some number. So everyone will have a different username. And then the password for this, so this will be your Tappis username. And the password for that is the same as the username. So these are just temporary accounts. It'll go away after today. So you can just copy paste the username into that field, and then also into the password field. And that sets up the Tappis authentication. So the next step is to actually authenticate to Tappis and get we call it the access token, or JWT, the JSON Web Token. And so that's just running in Excel, and it uses that username and password as well as the tenant and URL to get a token, which should get printed out. So this is really good. This shows you what came back, because you don't normally see this. It's being printed out here just to show you what a JWT looks like. It's a base 64 encoded JWT, and it decodes it here for you, so you can show what's in there. There's certain claims and other things inside of here. And by default, actually, so when you do it this way, you get a 4-hour token. So this token will be good for 4 hours, which fortunately covers the tutorial. So this should be good for the rest of the session. But like tomorrow, if you do it, you'd have to do it again to get another token. Let's see what else to say about this. Oh, it is digitally signed, so you can't just change the claims and re-encode it and send it into Tappis. Tappis will detect that tampering and will reject it. So we do have a public-private key pair that gets stored in the security kernel part, which Joe talked about a little bit. So there's security there. So once you see this, generally you're good to go. So someone
Steve,
asked, yeah, go ahead.
could you slide back up to the inner training account information slide so we can kind of base it off of yours? Oh, yours doesn't have anything.
So what are you looking for again? Like which one to enter?
Yes, where we're supposed to paste in.
Sure. So when you run cell, I can run it again and show you. So when you run this cell, you'll be asked for username. So this is basically like your TAPIS username. So it's same, the username and password are same. So you should have something like, I guess, 17 gateways 23-17 for you, James.
Oh no, that wasn't the issue. I was trying to change the code.
Oh, okay. 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 So did you?
So, oh, go ahead. So
Are
if you had
you-
a TAC account, for example, this would be your TAC username and your TAC password. And
Right.
you should be able to get a JWT in the TAC tenant.
Right. Just to interject, and Steve said it, but the URL is really important here, right? These training accounts only work in the training tenant, these training accounts and these training passwords. So if you had a TAC account, as it happens in TAPIS, we've set up actually multiple tenants, but in particular a tenant called TAC, where TAC accounts are accepted. Right. So, but that partitioning not only partitions the TAPIS resources themselves, the systems, the apps, the jobs, but also the accounts and the universe of accounts that are accepted. So just something to keep in mind.
Yep. Thanks, Joe. So if you want to you can run this entire notebook by changing the tenant just to TAC instead of training to TAC and giving your TAC credentials as Joe said. And you would be still able to generate a token and everything should remain same.
So one thing, important concept to keep in mind is that the username you put here is in general not the same as the host username you would use to, say, log into Stampede 2. Now in TAC, it happens to be, in the TAC tenant, it happens to be true that it's the same generally. But in general, the username you're using here is the TAPIS username, which in principle is entirely separate from the Linux login username, for example, that you would use to log in. And that's where this other password comes in. Actually, we'll be setting things up to run an application on a VM host. And so that a VM host has the same usernames also, again, well, I believe that's true, but the password is not the same because it's actually the Linux host login password. So that's why there are these two passwords. There's one for logging into TAPIS and then one for actually so that TAPIS can use SSH to connect and log into this VM host.
Yeah, and this token that you see here is good for accessing all the TAPIS services. You can, when you are using curl command, you can just grab this, export this to a token variable, and then using the header, TAPIS token header, you can just use it along with that and simply use the curl request. And since we are doing this SDK, it's going to remember every time we access any service with client dot. For example, let me show you one example and then we'll go more details into it, like client dot systems. So we are accessing that system service with the same token. And this is the individual call that we will discuss more once we talk about the system service in general. So I think until here, if you are able to pull a token, I think that marks successfully, you'll be able to generate a token and we can go deeper into each services. I think we have few things in chat.
Actually, I don't not see anything at the moment in chat. So
more.
I think,
okay.
Yeah, so I think we'll maybe go ahead, but if you do have trouble getting that token, just go ahead and interrupt us, please, and let us know. And we can, work on that. So maybe we can go to the slides now.
Sure, yeah.
Thanks. I think it's number 32, page 32. Okay. They're actually in a different section here. This slide deck used for other tutorials too. Okay. So I'm going to talk a little bit about, so I'm a developer on TAPIS. And particular, I'm focused on the system service and the application service and some other things, but I'll just talk a little bit about creating these resources. So we'll go back and forth a little bit between the slides and the hands-on part. So
Oh,
Oh,
did it pause my screen sharing if I put it in the presentation mode? I
I think
think.
maybe it did. It says just, I'm just seeing loading at the
Yeah,
moment.
it says paused.
Oh, interesting. Maybe
So
that's, oh. Yeah, I
yeah, I
I
think
can,
I put it in the slideshow mode and then it just paused.
and it just pauses. Interesting.
Yeah.
So I think this seems pretty good, I think, so.
Okay.
At least I can see it. Let us know if you're having trouble seeing the screen, but, so yeah, so first I want to talk about what's probably one of the first things you want to do if you're using Tapas once you have that token. And if you don't have any systems available to you, which actually you might have systems available to you that other people have created, but you're probably going to want to create a system. So in Tapas, what do we mean by a system? Well, basically it's an abstraction of a host or cluster that's identified by a name or IP address. And it's used in various ways in Tapas, restoring and retrieving files and data, and running a job. You know, when you run a job, it stages files to this Tapas system, what we often refer to as the execution system, and then launching the job and running on the system. And then once the job is finished, archiving the files and data to either the same system or possibly a different storage system. So here are some of the top level attributes, by the way. For more information, the actual GitHub pages, the tutorial material has more details, and then we also have live docs available, which you can see sort of in more raw form exactly what the API looks like. Yeah, and then we have read the docs, which is the most information, so which goes into depth on various services and has quite a bit of detail there. So the different levels. So I'm just going to talk in the slides about some of the more important attributes and properties of the systems and apps. So one thing we have is the system ID, which is a unique name within a tenant. Remember, things are isolated by tenant. A unique name within a tenant for the system, and then the host name, which is how Tapas can contact it using whatever protocol. The type, we actually support 4 different types at the moment. Linux, which execution systems must be Linux, but we also have other types for storage like S3, AWS buckets, for example, iRods, and then Globus. And so that host actually is not always necessarily looks like a host name. It might be a Globus endpoint ID or collection. And for AWS, it would be enough information to reference something like an AWS bucket. And then some other things like the owner, which is important, which is going to be you once you create a system. You as the requester sending it in will be the owner of the system, that Tapas user. And then another important attribute is this effective user ID, which is the user that's used when Tapas contacts this system, the host or like a Globus endpoint. That's the one that will be used for login. And then the authentication method for login. Support, in some cases, different authentication methods. Like for Linux, it's either password or these PKI keys or SSH keys. So today I believe we're going to use password, which is going to be that VM password. So when I mentioned that one important concept is this effective user ID is not necessarily the same as your Tapas user ID, although in this tutorial actually it is the same. So, and as I've been talked about quite a bit by Joe and Nathan, we have different ways of actually getting to making calls to Tapas to do these things. So I think, is there another slide? Anagha, what's the next slide?
On apps, so maybe we can show them.
Okay, yeah. So we're going to switch back to the notebook now.
Yeah.
And actually create a system.
Yeah. Before I think we will need these 2 pieces of information: VM password and host. So again, these you will find on the Google Doc. And it will be the 3rd column. That's your VM password. And the host is the IP address of that VM. which is going to be same for everybody. So okay. And once you have these two things put in here, then building a system here. So yeah, Steve, do you want to explain any of this?
Sure, yeah. So these are the attributes we were talking about earlier. There's the ID, which is typically a short, some hopefully descriptive name like Stampede2. The description, which is more verbose, optional attribute. The type, the host name, which is the IP address in this case. Then how we're going to authenticate to it. How Tapas will authenticate when it contacts it. And then I didn't talk yet about root-dir, which is another important attribute. And basically what that does is let you set up a system so that anyone goes to that system from Tapas will actually be, all the paths will be relative to this root-dir. So depending on how you set up the system, this might be simply slash, meaning that everyone would use the normal paths, or it might be some project directory, or in this case, we set it up so that when people go in, they go in as their own username, and their paths will all start with their home directory. And the other attribute is whether you intend for the system to be used for executing jobs. I think in V2 that we actually distinguished between the two, whether it was a storage or execution system. Here it's indicated by an attribute rather than a separate system type. So that you can create, each system basically is effectively a storage system. It can be used to store files and then list files, things like that. But this indicates, in addition, you want to allow people to run jobs on this system. And then there are a number of job-related attributes. There are just a couple shown here. The job runtimes, what runtimes does this support? We currently support Singularity or Docker. I believe the default is Docker. So in this tutorial example, we're going to actually be using Singularity. And so this system is set up to support Singularity. So this attribute basically tells Tapas that yes, you can use Singularity on this system. And the job working dir is another job-related attribute that basically is information for the job service when it goes to build all of its paths to launch the application. It will do everything under that particular directory. So in this case, it's relative to that root dir. So everyone on their VM, if they were able to go there using SSH, they would, once they run a job, they should see a directory /home/ their user ID /work dir, and then everything would be under there. So let's go ahead, create a system. When we run that, it should create a system, and we get back a URL there. And so that's now our system's been created. And then another thing, which I think we won't need to run, we can in the next cell, you can actually update your system, at least most of the attributes. So here we're just showing you how you can use patch to update certain attributes of the system. I think there was a question. Yeah, just got answered. So someone asked about SSH, and yes, by default it's port 22, but that is configurable. You can set it up to use a different port for SSH. So, okay, and then let's see.
One thing you mentioned, Steve, was like
Yeah.
these system IDs are unique throughout the system, throughout the tenant. So if they try to run this again, this should fail. I think we can show them.
Right. This is a tenant-wide
yeah.
unique ID. So it's important to keep that in mind, especially if you're one of the first people to start creating systems. If you create one called Frontera, then no one else is going to be able to create that system name. So that's something to be aware of. And I mean, of course, you can always create a support ticket, and we can go in and change things if necessary. But you can change ownership of systems, so that's something else to be aware of. Okay, thanks, Anagha.
Yeah. So if you have clicked this cell multiple times, you might get that error again, like system already exists. Okay. So let's see how many systems we've got. So everybody should see at least one system that they have created. And if you want to see the details of that system, maybe just click on the self fetch system, get the system, and you're giving system ID, the one that you have just created. You'll see a lot more attributes here.
So there are quite a few attributes in systems, a system, resource, and then you'll see in applications, the application actually has even more. And there's some overlap between them, which I'll talk a little bit about in a bit.
So is
Okay.
everybody able
Yeah.
to create a system, or any issues anybody facing?
Okay. Yeah, so hopefully everyone's been able to create a system and then list it. They could see it. Okay, good. Thanks. Yeah. For letting us know. So now we've created that system. If we actually tried to say list files using that system, it wouldn't work because we haven't let Tapas know yet what the password is, the auth credentials. So the next step normally is to go ahead and register your credentials for that system. And it does validate, by default, it does validate the credential when you register them, which you can skip in case you haven't finished setting things up. But so if you have the wrong password, you should get an error here that it wasn't able to register the credential. So now once that's registered, you can list files and see details about the files doing this listing. So that sort of validates that you set everything up correctly, including the password.
The list of files here are relative to the root directory that we have set up. So basically the path that you have provided.
Right, so you would need to prepend the root dir to find the absolute paths on the Linux system for these files. And Jamie pointed out, be careful if you have lots of files, you'll get lots of output.
Yeah,
So
that's true.
And then, so next we're going to create one for an HPC type system. Because the previous one was for a typical VM where you.
Sorry about that. It just
That's all
logged
right.
me out.
Right. Yeah, I've had that
I
happen.
know this happens a little bit.
So for an HPC type system like Frontera or Stampede 2, usually you need to provide more information. A lot of job related attributes are available there. So here's an example of doing that. And so we have the sort of the same ones we had before with can exec is true and the similar runtime and working dir. We also have this can run batch, which indicates that, yes, you do intend for the system to be one where people are, where we do support batch jobs. So jobs uses this. So if someone were to attempt to run an app on a system that didn't support batch jobs, and they were trying to run a batch job, it would get rejected right away. And so you need to provide some additional information, including what scheduler type. I'm sure I won't talk much about scheduler profile that lets you set up certain modules and other things that are common at TAC, for example, or maybe different for different centers. And then information about the different queues or partitions that Slurm queues or partitions that are supported on that system. And there's some, various attributes there, which I won't go into detail. So I think maybe we can just go ahead and create that system, unless anyone wanted to add more about the system.
So using the same call create system, but this time we're passing the different system definition here. And I think now when we list systems, it should show us 2 systems that we have created so far. The HPC one that we just created and the VM one. So basically.
And you see you get, just what we call the summary attributes there for each ID. You can't actually choose, you can search systems and choose to display different amount of information. Like you could choose to just display the ID and the host name, and then you see less output. Can be convenient. So, and then you can get the details again. This looks very similar to the previous system. Just some additional information on HPC related information. And again, we need to register our credentials for this particular system. So we do need to register credentials for each system. So that's the one thing we are actually looking at improving in the future, this credentials management, because here, like in this case, it's the same credential. It's just we're creating two different systems. Right, so someone was, thanks, Joe. Joe has answered a question about the fact we only support Slurm at the moment as far as the batch scheduler type.
Yeah, and it's not that we, don't want or have anything against SunGrid Engine or any of the other ones, which we did support in V2. It's just we haven't had much demand or requests for any of those other ones. It seems like a lot of centers have moved to running Slurm. So that's great, but yeah, it wouldn't be a huge effort to add support for additional schedulers. So I imagine at some point we'll probably add them.
Thanks, Joe. So I think that wraps it up for systems.
Systems, yeah. We can
go back to the applications now. So yeah, once you created your system resources, and you can do things like list files, upload files, download files, delete files, make directories, and then transfer files or data objects between systems. But you might want to do more than that, like run a job, run your application on a system. I think there was a question about MFA. Yeah, that's a long topic, MFA. So yeah, we can talk about it at the end,
we can briefly say that MFA is a difficult challenge for us right now with TAPIS, and we essentially have to bypass it. In a nutshell, we have to bypass it one way or another. Now we work with different sites and different HPC centers to essentially make an accommodation for that. So we have. I like to say basically right now what we have is just nothing but band-aid solutions. We have also though been talking to a number of HPC centers, including San Diego Supercomputer Center, Ohio Supercomputer Center, University of Hawaii, about a real solution. And that's something we've all been thinking about, right? Because MFA is important. On the one hand, it's very important, but on the other hand, it does the way it's kind of often done at HPC centers just out of the box, it does cause a real challenge for automated workflows. So we're in the process with those groups and some other folks of designing a real solution that wouldn't be just a band-aid. Yeah, that's a whole nother talk, but yeah, hopefully we'll have something more to say about that in the coming months.
Thanks, Joe. So probably I'll try to go over applications fairly quickly, and then maybe check to see if people want to break after that. I know it's been over an hour. So application, what is an application? Well, basically it represents all the information that's needed by the job service to execute your code on a system and produce useful results. So it's versioned because you might be doing an application for a group of people, and you might want to release a version that works a certain way, and then everyone can use it while you're working on the next version. We support the containerized executables, as Joe mentioned, and they'll run at the end of the day, the jobs will submit them on a particular execution system. So they're what's involved in running a job. It's the job service will stage input prior to launching the application. I will launch the application, and then monitor it while it's running, and ultimately archive it either to the same system, somewhere else on the same system, or possibly to a separate remote archive system, storage system. Let's see, I think next we talk about, some of the top level attributes for an application is the ID and version. Those two together must be unique within a tenant, just like with the system. And then the owner, which you'll be the owner when you create one. The runtimes that are supported, which will be Docker and or Singularity. And then another one is a container image that represents your executable code. So it's a reference. So for Docker, it's hopefully you're very familiar with Docker. Like there's one that points to the Docker Hub Hello World container. So that's used to actually launch your application. And then similar to systems, there are quite a few job attributes. Then in this case, it just shows a couple, a description, and then so one thing you can specify in addition to a lot of the other job attributes is what exec system will that run on. So so you can see quite a few details here, and quite a few. Those are just some of the at a high level, some of the attributes, but there's some tables below that give details on all the various attributes. So one thing I did want to mention is, or maybe we'll wait till jobs. So, well, no, I guess I should mention it now. So one thing to be aware of is there's overlap between these job related attributes. So when you go to submit a job, you'll have a job submit request that goes to the job service, which has information in it, which we'll talk about in a bit, but it can have in there a lot of the same attributes you see here. And there are even a few attributes that are defined also on the system resource. So this gives you a lot of flexibility, for example, in the exec system. So in your app, you can define your application, for example, to execute on the Stampede 2 system. Actually, that's optional. You don't actually have to specify any execution system ID in the app definition. But you could say, by default, this app will run on Stampede 2. But then at runtime, you might want to actually run it on Frontera. Well, in that case, you would specify that execution system in the job submit request. And it would override what's defined in the app. So there are quite a few attributes that, have this, that overlap, and have this precedence of the job submit request value has precedence over the app definition value, which has precedence over the system resource value. Aren't that many on the system, but a few. And there are a few, and it also is possible, though, to define something like an application argument that's fixed by the application and cannot be overridden. So there's a fair bit of flexibility there. So I think it'd be good for apps at this level. We can go actually create our app. Now, and it's going to be a lot like the system. You'll see this JSON definition. And here we're creating what we call a forked, an app that's intended to run as a fork as opposed to a batch. So basically Tapas will just run it directly from an SSH session using Docker as the container runtime. And then and there's a reference to the Docker image. And here we've got a few job attributes that are defined. And there are quite a few more, but we're not going to be using MPI this time. There's support for MPI. We also have application a parameter set, which is a collection of different types of arguments. There are container arguments, application arguments you can specify here, as well as some scheduler options if it's a batch job. So here we're defining a couple of application arguments that will get passed into this application, which unfortunately we don't have time to go into a lot of detail on. And the other important thing here are the file inputs. Basically, this is telling Tapas what files to transfer to the execution system before launching the application. And here, let's see, I think, this doesn't have a lot of detail in it, but you can put things in here like the source URL, where it should come from. And there's a special Tapas protocol you can use saying that I want to transfer this file from a TAPA system to this location on the execution system. So there'll be a target path also. And then, so TAPIS will do all those transfers prior to launching the application. So let's go ahead and create our application. So, it's already been run. So it's created an application called npm Docker Gateways Training 3. And so now we should be able to list and see that application. And so there's just the one so far. So hopefully everyone's very easily following along and executing these cells and not having any problems. So here, just showing how you can, when you get an application and you don't specify the version, you get the latest version of it. But you can also reference particular versions. So this shows you all the different attributes that are part of an application, like file inputs, and in this case, well, not because time to really go into a lot of detail, but file inputs, application arguments, and there's ways to control what gets archived at the end. You can exclude certain files from getting archived, and whether or not you want to include launch files, things like that. So, okay, that's pretty quick. Quick summary of what. Go ahead.
Are people able to create applications and see the details of that application?
Hopefully we've still got everyone and everyone's still awake. So the next thing we're going to talk about a little bit is the job service, which I actually mentioned quite a bit before. But basically now that you've created your systems and your application, you're ready to run it on a system somewhere and then share your amazing results with the world. So we'll talk a little bit about that. One thing I did want to mention before we get into this more, though, is, it's also possible to, talking about sharing, it's possible that your system and app will already be created and you'll just be running it. So it is possible to, someone else has set things up and you just need to run it and then, work with your results and your input data. So the job service, so of course it manages running your application on the system and then seeing what happens with it, letting you know, and then archiving the results somewhere afterwards. It's focused on running containerized applications on any host that supports the container runtimes. So currently it's only the Linux type that can be made as an executable, a system that supports job execution. And of course, we mentioned Docker and Singularity, although we do have in the work support for what we call a zip runtime, which would be a third alternate where you could basically create an archive, like a tar archive of all your code, and use that to run on a host. And the job services is built on all the other three core services: the systems, applications, and files, and of course all the ones supporting that, like the security kernel and the authentication stack, and the tenant service. As Joe mentioned, there are quite a few services. So when you run a job, it actually has a lot of different stages it goes through. When you first put in your job submit request, which works like the other calls, you'll basically have a JSON block. If you're calling it TAPIS directly, you have a JSON structure that you send in, and then you'll get back a job ID, and the job will initially be in the pending state. And then the job service will pick up that job and then start processing it with a background worker thread effectively, and go through the inputs, sort of validate everything. And if everything looks good, we'll move on to the staging input stage. And that's where it's transferring files from the various locations to the execution system. And then it will stage the job, basically meaning it will make sure all the application, sometimes they're referred to as application assets, are there and set up. It actually will create a shell script that will launch the job called tapestjob.sh. And then we'll go into the submitting state where it's actually launching the job, which if it's a batch job will be an SBatch, a Slurm SBatch command to submit the job. And finally, assuming that went well, it goes into a queued state where it's waiting on a queue or partition to accept it and to start running. In which case, once that happens, it goes into the running state. And some of these states can last quite a while, but jobs will just continue monitoring your application and letting you can get the status of it. So it monitors it while it's running, and then once it's finished, it will go to the archiving stage to archive your output, and then finally it will be in the finished state if everything went well. And as mentioned below, there's some other states that it can be in, like failed. If something went wrong, like if your application returns a non-zero exit code, for example, it will become failed, or there was some other problem. And like it couldn't transfer one of the staging inputs, or required file input couldn't be transferred. It would fail. Or you could be the job was canceled. Maybe it was in the queue for a long time, and the user decided they didn't want it to just stay there. It was time to give up and cancel it or try something else. Also can be paused or go into a block state. Sometimes things can happen that it's not, TAPS isn't able to monitor it, for example, and is not able to determine the status. It might go into the block state for a while, which and you might want then to create a support ticket to help troubleshoot what's going on. And then it can become unblocked. It can recover and then become unblocked. Maybe if there's a network issue, this kind of thing might happen. So that's the pretty much the full life cycle of the job. So yeah, as I mentioned, this is very similar to actually creating a resource here, in the sense you are creating a job resource. You're launching your job, and at a minimum, you provide the application ID and the app version. So you have to tell it what app you want to run and what version of that app, and everything else is actually optional in general. So you can get the job a name, which is really just for your reference, your description. I think it's also a description attribute. And then, but you can also here, put all the job attributes here, such as the application arguments. You might have container arguments, or scheduler options. Then all your file inputs can go here. And then archiving, whether you want to archive to like a remote storage system, for example. Now, a lot of this can, as I mentioned, a lot of this can also go in the application, be built into the application itself. So if and then things can be overridden here, depending on how they're defined. So let's see, we've got our definition there. Yeah, I won't go into a lot of detail about that, but yeah, so I think we can go on back here and okay, so yeah, so now we can actually run a job and see what happens. So this is that, which I think Nathan will talk more about in a little bit. This is the job.
So here, I think we're
Nathan,
going to run two jobs. First, on this using the same application, we're going to submit it on the first system that we created. So we'll try to run that and see the job response, and then we're going to run that same application again on the HPC system. And then I think after that, we're going to do the workflow stuff. So let's try to submit this job. And you can see how the job response looks like. So job submitted for this application. And then as Steve mentioned, there are like these parameters like archive system directory. This is where you can find the job output directory put in. Here, the archive system is same as our execution system. And then there are a couple of more directories that you can see. There's an execution system directory, input directory, output directory. You can see the job type as fork. And the important thing is, like, when it submits a job, it first lands into the pending state. So we can check the out, like from here, let's get the job ID and see the status of the job. So job should be in one of the states that Steve explained. This was pretty quick, so it kind of finished. But if you can again try to submit it and see what status the job lands in. So this is what we submitted. We got our job response. This is the second job that I'm submitting on that same application. So every time you see different job UID. And now you see the job is currently running. So if you keep checking the job status as it progresses, it will show you different statuses. So it's still running. And here in the job list, you will see that we submitted 2 jobs. So the summary attributes for jobs list again. Let's see if our job finished. Yeah, it kind of finished. I hope everybody got a similar status. If not, let us know. If a job fails or something, you see different status for your job. I think this is where you can download the output. So using the job output download on this output path, let's see what we have in there. This is currently how your job output file looks like. It's like a bunch of warnings and stuff. You can give it a different output file path, and then it can just download output from that particular path that you have given. But this basically tells us that the job successfully finished. And I think as long as the job is not in the terminal state, you can just cancel it. You're giving it the job UUID. So one thing about job UUID is, like, it's always like a unique number that ends in 007. Anything on the job execution, Steve? Did you want to add, or
Maybe not. I guess can we go back up to the submit request JSON?
Sure, yeah.
Just trying to think if there's something in there that actual JSON. Where do we have that?
Here.
Up higher, little higher. We have the.
Oh, this is the response submit job.
Oh, right. Yeah, it's all
we don't
built.
have
It's all
JSON.
built in.
Yeah.
We actually don't have the. I see. Right. It's all there. Right. So we don't have other things in there. Right.
Yeah.
Okay. No. So. I don't know. Did you want to run the HPC one or?
Yeah, let's try to run the HPC one.
Which run it as a batch job.
Yeah.
It's actually on the same VM, which actually is set up to support Slurm installed
yeah.
and Docker set up to support the same.
Okay. So we submitted this job. I think it's the same place like the work directory, but it creates a different folder by the job ID every time. So you'll find your output in that job UID folder.
Oh yeah, that's a good point. So those are the default directories. You can actually specify that directory if you want, but by default it has a certain sort of templated it goes by the job ID, so you have a unique location, but it's actually possible to put in a static, a fixed directory there, in which case your job would always run in the same area, which usually is not what you want, but it could be. So.
Okay, I think our job finished. Again, we should see a similar output file that we saw before. This is exactly the same application. The only difference being that we're running it on a HPC-like system now. So yeah, I think if you are able to successfully run the jobs, I think that pretty much concludes the way how we create systems, define applications, and run applications.
Other jobs.
Jobs,
Oh,
yeah.
Anagha, do you think there's time to cover permissions and sharing, or
Yeah, I think
Yeah,
I have
okay.
enough time. I can
Yeah,
back
go
to
back
the
to the-
slides. Yeah.
yeah, so I think, yeah, go up. Yeah, that's good. So now that you've run your job, have some output, you've got some amazing results, you probably want to share it with someone or a group of people, or maybe everyone in your tenant on your project. So Tapas supports that type of access control, when people are going through Tapas. So we have fine-grained permissions where you can grant a user or a collection of users read or modify permissions on the resources, like a system or an application, or even a file path on a system. And one thing to keep in mind, these are Tapas authorization permissions. They doesn't actually change what happens on a Linux host. So even if someone has, say, modify on a system, on a file path for a system, and they try to do a make dir, if that user they end up logging in as doesn't have Linux permission to do the make dir, it will fail. Operation will fail. So there's always the Linux or native permissions on the host. It doesn't bypass that. So one thing though that does happen is, if say you spend a lot of time, you created an application that you plan for other people to use, maybe your entire project, which can take a while, by the way. Designing a reusable application can be a fairly big project and take a while. So let's say you've got this application that you want people to use, and you want to share it with everyone or a set of users. If these fine-grained permissions, it turns out, are a very awkward way to do that, because you actually need various permissions. You'd need read and execute on any execution systems. You would need read and execute permission on the application itself, and then the file path permissions, ones through Tapas, get involved. So you would need modify on some and read on other paths. So it actually can be very awkward and tedious to grant all these fine-grained permissions. So Tapas actually also supports a higher level approach to granting access, which we call sharing. So I think the next slide talks about that a little bit. So that's just a reiteration of the previous point about, we have also this concept of sharing. And so basically sharing, what that ends up doing is granting certain access to a group of users or everyone in the tenant. We call that public, sharing publicly, certain implicit access to what I think of as downstream resources. And probably the most useful and interesting example is, so you've created this application and you want everyone on your project to be able to use it, so you can share that application publicly. But you also need to be aware that what that does is, in the context of running a job with that application, it gives people certain access through Tapas that they wouldn't normally have. So maybe there's a system that's been defined that they are not normally able to execute a job on. Well, if you share the application and that system is the exact system defined in that application, so there are some restrictions, but then they would automatically get access to that system and the paths on that system in the context of running a job. So once you share an application, it's possible they can run a job, and that process of running that job, it will make certain directories, like the ones involving the job ID. But if they actually tried that going directly to the file service, the user you shared it with, they wouldn't be able to make the directory, potentially, because they wouldn't have the right permission, that certain fine-grained permissions. So it basically lets you to easily, once it's properly designed, the application, it lets you easily, share your application with other people to and allow them to execute jobs with it. So that's a pretty quick summary of sharing. And I think that's it in a nutshell. So see if anyone has any questions.
Sharing exercises here, but maybe you can just show you. Calculating, get share info. Yeah. So you can get the share info of your application. Application ID. I think it will need app version also, right? Let's see if this gives us any information. Yeah, right now it's not shared with anybody, or neither it's public. So we can change the share permissions and stuff.
Oh, one little gotcha, by the way. Very minor note, that false there with the capital F is because we're using TappyPie. If you were using curl or something similar, that would need to be a lowercase f. So just something to be aware of. It might caught me a couple times.
Yeah, that's true. Okay, any questions so far until here? Think not, we can move on to the workflows part.
All right. Okay, I'll be presenting the workflows portion of this tutorial. Because we're going to be doing CI/CD, which involves building an image and pushing it up to a registry. I probably should have mentioned this at the beginning, but you will need a Docker Hub account. So your Docker Hub username and a personal access token. In order, we're going to provide this to the image building technology called Kaneko, and Kaneko is going to use that to push your image to your registry. So I guess, Anagha, maybe we could go through the flow in the web browser of getting a Docker Hub personal access token. Can we go to hub.docker?
Do you want to share your screen and show that part, and until then I'll figure out the token.
Sure. Let me get everything set up real quick. Oh, that's why. One second. Let me get logged in to Docker Hub. And I will begin sharing. Okay. So first step to generating your Docker Hub personal access token is you need to log into your Docker Hub account. So I suppose I'll just sign out and then I can go through that process with you. There we go. Okay, so we're at hub.docker.com. We're gonna hit the sign in button. Your info, login, username, and password. It's been a while since I've done this, so let's see if we can do it quickly. So we have at the top right, you'll see your username and a little drop down arrow. Go ahead and hit that drop down arrow and account settings. In account settings, I do believe we go to the security tab on the left sidebar there. And now we're going to hit the new access token button. Give it a description. and then the permissions that you want to have. It needs to have at least read and write access to push your image to the repository. So give it read write and hit the generate button at the bottom right of the modal. There we go. We have a new personal access token. Copy it, and now, Anagha, I'm going to stop sharing my screen. If you would, well, if I can, there we go.
Thanks, Nathan. Share my screen. Okay, so to talk, when you run this cell, it will ask you for your Docker Hub username and the personal access token that you just generated. Put that in here, and then just try to run that cell.
If you had any troubles generating a personal access token with Docker Hub, please let me know. I'll wait a few moments, and then if we get no thumbs down or X's, then we will move on.
Once we generate the token, where did we actually put that?
So it's going to be in the first cell under the Docker Hub credentials section. When you run that cell, it's going to prompt you for your Docker Hub username.
Oh, sorry. Yep.
And then it'll prompt you for the password.
Okay, which that would be our Docker Hub username and password. You said.
That's correct. So it'll be the Docker Hub personal access token that you generated on Docker Hub.
So for generating the personal access token, I think if somebody missed it, then you just log in to your Docker Hub with your Docker Hub account and go on this tab here, go to account settings, and in the security,
that's right.
You generate a new access token.
Yeah, looks like I'm good. I got it in.
Great.
Sure.
All right. So the next step is we're going to create a group. Now this group is only going to have you in it, and by default, the owner of the group has full access to all the resources within that group. So go ahead and run the group cell. And we get a response that it was successfully created. Now we want to create a pipeline. And first, let's see if you can scroll down all the way so I can see that full cell there.
Yeah.
We're going to do the entire pipeline and task creation at once. You can create pipelines and then add tasks to it later if that's a workflow that you like better. But what I'll do is I'll go through each of these properties here and give an overview of them and their importance, and then we're just going to run the cell, which is going to create our entire CI/CD workflow. So each pipeline must have a unique ID within your group, and your group must also be unique within your Tapas tenant. So this is just standard workflow, so it's of type workflow. And we have a property called execution profile. This tells the workflow engine. So as I mentioned, there are two major components to Tapas workflows. One is the API that allows you to create and persist these workflow objects, and then the workflow engine, which is responsible for taking a workflow definition and running it. So the execution profile is it's a set of properties that you can use to modify the way that the workflow engine runs your pipeline. So retries is pretty self-explanatory. If this pipeline fails, meaning that if any task within this pipeline fails, we're going to retry it 0 times. You can set that as many times as you want. There is a maximum execution time. So if you do rerun a pipeline multiple times and it fails every single time, it's eventually going to run into the max exec time, which is the maximum amount of time that a workflow is allowed to run. And I believe the maximum value for max exec time is 3 days. So you can run, you can imagine that, a lot of high performance computing workflows, sometimes they may need to process data over the course of, over a very long time, right? Like multiple days. So that's also subject to change. There's no hard, set reason why we chose 3 days, but yeah, it could change at any time in the future. It could increase. So then we have the invocation mode, which is asynchronous, which means that all the tasks in your pipeline will run asynchronously if they can. Then we have the duplicate submission policy. So what happens if you submit a pipeline and then resubmit a pipeline with that exact same definition? How should the workflow engine handle that? So in the case of CI/CD, what are we doing? We are building an image, and we're going to test that image, and we're going to push that image up to a registry. So imagine we submitted, so with this terminate duplicate submission policy, what we're saying is that the new pipeline that we're submitting, if there is already a pipeline running with the exact same data, we're going to terminate the current running pipeline. And that's important because perhaps you made you submitted a pipeline to do the CI/CD, and then you realize, I forgot to add this little bit of code, and then you push that code to Docker Hub and then trigger your workflow. You want that new image build to be the source of truth and not the one that came before it, right? So what it's going to do is it's going to stop it dead and start the workflow again with the new data. There's also a duplicate submission policy of deny, which prevents the new workflow that's being submitted from running at all. It'll just keep running the same workflow that was already running. And then there's allow. So no matter how many times you press, the run pipeline button, it's going to run all of those pipelines, and all pipelines run in parallel. Well, I should say all pipelines run concurrently. Tasks absolutely run in parallel because tasks are executed in containers entirely separate of the workflow engine. So now we talked about the execution profile. Let's talk about the tasks. So I had mentioned that there's 6 different task types and more task types on the way to perform certain kinds of work. So each task must have a unique ID that it must be unique within the pipeline. It has a pipeline ID that it belongs to, the group ID, and then we have the type of image build. Now, tasks have various different properties that are required for the various different types that there are. One of those properties on the image build task type is the builder. So there are 2 options available. One is Kaneko, which is a containerized image building application that does not require Docker. So basically you feed it a context, which in this case, it's going to be a GitHub repository. And what it's going to do is it's going to pull down the GitHub repository. We specified the branch as main and the URL where that can be found on GitHub. And we specified the build file path, which is just Docker file. So in the root of the project, well, after actually within the sub path, so it'd be material point method, npm dummy source, Docker builds, and then Docker file, it will build that. And you specify the visibility in the context, whether it's public or private. So if it's private, it's going to require that you provide some GitHub credentials in order for Kaneko to pull that down. Looks like we have a question or two. Okay. So yeah, if you want to delete a group, there is a delete group endpoint, and you can find all of the operations that you can perform on the Workflows API in the Tapas Live Docs. And I believe delete group is in there. I think it'll be in Live Docs. Can we go to the Live Docs?
Yeah.
Yeah, I wasn't able to find the delete group method. I was looking for an answer for Jennifer, but maybe I missed it.
It may not be published in the Open API spec, which I will add to the next version. Pipelines, yeah, you can go. Oh yeah, group. Sorry. Yep, it's not there. Okay. Looks like it just wasn't published in the Open API spec. It does exist. Okay. So deleting a pipeline, that endpoint is definitely in the Open API spec. Okay, so we talked a little bit about the context of the image that we're building, pulled down GitHub repository, pointed to some Docker file, and built the image. Now we're talking about the destination. So we want it to go up to Docker Hub. And what we're going to do, since in the previous cell, what we did was create a Docker Hub username, or set a Docker Hub username and a Docker Hub personal access token. It's going to take that username and construct a URL out of it. So in this case, Anagha's username. And we're going to tag it with gateways test. And we're going to provide the credentials in the destination itself. Obviously, if you're trying to push to any Docker Hub registry, it's going to require that you provide credentials. So what Tapas Workflows API does on the back end is when you provide these credentials, if you want to run a workflow, if you want to run a pipeline reproducibly, it'd be nice to not have to provide the same credentials over and over and over. So we leveraged Tapas security kernel to encrypt and safely store your credentials for GitHub. So the only time that these credentials are ever accessed within the application itself is when it sends it over to the workflow engine. And once the workflow engine uses those credentials, it is discarded. And there's no remnant of your secrets. But this allows workflows to be run the same every single time. So that is the first task, and you'll notice that there is a lack of one property, which is the depends on property. This is how you specify dependencies of tasks. So that means that this task will run first, and all other tasks that are specified within a pipeline that don't have any dependencies specified, those will run first and in parallel. So now let's go on to the two tests that we're going to run using the Tapas job type task. So for Tapas job, it has one single property that is required, and it is literally just a Tapas job definition, exactly like we ran in the previous cells when we were demonstrating the jobs API. So we provide a name, description, material point method. We're using that exact same app that we created previously. That's going to be the app that we're going to run, which happened to be a test to ensure that npm was compiled correctly. And then we're going to be running another test, which is to make sure that the application code actually works. So I'm not an npm expert, but whoops, sorry. Yeah, I'm not an npm expert, but so npm is material point method, which is it's essentially a way of simulating materials, whether it be solids, liquids, or gases, under certain conditions. So let me go back to my screen here so I can see where we're at. Okay. So we don't know much about material point method, but we do know that this requires, in order to test it, we need to run this on some HPC resources. So if we can scroll back down to the tab as jobs. So as you can see in the dependencies, we have the first job that we're running depends on build npm image task, and the second job that we're running depend on the build npm image task as well. So we provided a TAPIS job definition in both of those to the TAPIS job def property. And if we can scroll down here, we're going to also use that the app ID and the app version, and then also the system that we created previously. And the difference is for this run, we're providing an application argument of directory input. This is going to be the actual file that's going to be run by npm to ensure that it has been built correctly and the application code is good. So let's go ahead and run that cell.
Yeah, I think one quick thing before we run it is like you should make this change in the destination and change it to your Docker Hub user ID. Otherwise, this will fail.
Well, it should work. I think what we had there before
Okay.
was actual Docker Hub username variable, right?
Okay.
So it might just work if they run it.
Okay. Yeah.
I think we had that issue like a couple tutorials ago, but we have
Okay.
rectified it.
Okay.
Okay, so now we have a pipeline. Okay, so the next step is going to be running the pipeline. In these little notes here, it mentions that we did specify the execution profile to terminate. So once we run a pipeline, any other subsequent pipeline that's submitted is going to cancel the previously running. So in this little cell, there's some logic to actually, I believe, to prevent you from running multiple, just so that there's no confusion or issues, because it does take some time to kind of clean up the workflow engine after a pipeline is run and terminated. So let's go ahead and run our pipeline. Oh, I'm sorry. I think, yes, it's going to, yes, this is going to run our pipeline. All right, we have successfully triggered our pipeline. So let's go ahead and check the pipeline run status. All right, our pipeline is active, and we can see there is one task execution currently. So a couple other objects that I didn't mention previously, while let's let this run. There are pipeline runs and there are task executions. So their names are pretty self-explanatory. Every time you hit the run pipeline endpoint for a particular pipeline in a group, it's going to create a pipeline run, and it's uniquely identified with a UUID. And when tasks are executed for a particular pipeline run, task executions are created, which keep track of basically the status of the task execution. So currently the npm image is active, the task execution is active, and hopefully we're going to see, fingers crossed, that it will properly build the image. Now this does take a little bit of time. Can you go ahead and run that pipeline run status again? Okay, it's a big image, so it's still building. And then what's going to happen is once this completes successfully, is the other two tasks are going to be executed in parallel. We could have constructed this pipeline in a number of different ways. We could have ran the first test and then ran the second test. So we would set the dependency for the second test on the first test. But because these tests are entirely independent of each other, we're just running them in parallel. So we're kind of showing off some of the functionality of the pipeline itself, of the workflow engine. So, okay, we can see that the npm image has been built successfully, and the 2 tests that we're running using the workflow engine that is integrated with the Tapas jobs API, we are running these jobs on an HPC-like resource. So these should probably not take too much time. It would be faster than the image build for sure. So we'll just keep refreshing here. And if anybody has any questions, there we go. We're completed. Excellent. So now, I guess a good way to test to see that everything worked, if you guys want to go into your own individual own Docker Hub registries and look to see if that image was actually pushed to your Docker Hub registry. Let's see. So yep, just go to your hub.docker.com. If you're logged in, it'll show the image. So we have the username /dummy npm, and then we have 2 minutes ago, the gateways tests version of this image was pushed to the registry. So big success. Did anybody else run into any problems? See a thumbs up. We like thumbs ups. Anything? Any thumbs down? Another thumbs up. Awesome.
Say, quick question if you got some time.
Certainly.
You had mentioned that some of the jobs you can create dependencies on them when you're structuring your pipeline.
Yes.
When you were describing that, it seemed kind of similar to, well, in the scheduler Slurm's capability of creating job dependencies and some of its own built-in functionality. So is this essentially like an abstraction of that built-in functionality, at least if you're literally using Slurm?
It's actually entirely separate. So
it is, okay.
Yes, because so in this case, we did happen to submit a job to an HPC system that has a batch scheduler. But when we ran that image build, that was actually run on the Tapas Kubernetes infrastructure, the Tapas Kubernetes cluster itself, within a container. So the workflow engine itself handles it manages the DAG, right? So if a job was submitted that say was dependent on another job, and by job I mean like Slurm job, that is not actually, that functionality, as far as I know, is not available through the Tapas Jobs API. Is that correct, Joe or Steve?
Yeah,
To specify
that's right.
Okay. But so you can specify your own dependencies in the workflow engine, or in the Tapas Workflows API, and it will handle all of that for you.
Okay. Which maybe this is another conversation that I can take offline and read through the documentation, but I'm just wondering in my head, the benefits of if I was to deploy a Kubernetes cluster in the Tapas platform on that, or if I was to use, I currently have a Slurm scheduler available on my local cluster. So I don't know if you have any thoughts of like the benefits of running this workflow in Kubernetes versus a traditional batch scheduler. I mean, it looks like it's very similar functionality, but
Absolutely. So I suppose that if your sole concern was to run jobs and specify the dependencies, and you're only ever going to run jobs on the batch scheduler, then you wouldn't need Tapas necessarily, or Tapas Workflows specifically. But Tapas Workflows is really, so I guess I could mention some of the use cases of Tapas Workflows that'll like help make this clear, whether you should use Tapas or just your batch scheduler, right? So we're currently working on supporting like general ETL workflows, and one of those use cases is the JPL NUID spectrograph. And so some things in this particular workflow or ETL pipeline do not necessarily need to be run on HPC resources. Maybe you just need to run some arbitrary code to do some like string transformation of a particular file, and then, well, first, take in that file from a Globus endpoint, do some transformation, and then run Tapas jobs over it. I suppose what you could just do all of that string transformation, all those preparation steps in that ETL pipeline in a job, like a Tapas job, for example, or a batch job, just some script. But Tapas workflows makes it really easy for you to just like specify, for example, in the function task, if you wanted to do your string transformation using Tapas workflows, you could literally just, if you've already written the code, you point at a GitHub repository, it pulls that GitHub repository down, runs your entry point, which does all the string transformation, and then and then you can run jobs on a batch scheduler to actually do the analysis of this newly transformed data. So I don't know if that helps or that makes things even more unclear, but yeah, hopefully
Yeah,
that
Nathan,
answers your
if I
question.
could maybe
Sure.
add something there. Yeah. So I mean, this is a good question, right? But I think I think the case of CI/CD itself, is a good example of, even if you want to run something on an HPC system where the workflows engine or, Tapas in general might help, right? Because, again, let's say you have some code that you're developing like material point method, and you're making changes to that code base, right? You're continually making changes and pushing those changes up to GitHub. What this functionality will allow you to do, right, is to automatically run jobs on a Slurm scheduler, and in fact, I think Tapas is actually more useful, frankly, in the case of Slurm schedulers than it is in the case of Kubernetes. But to automatically run jobs every time you commit code to GitHub, or every time you push to a particular branch in your repository on GitHub, right? So triggering, a pipeline to run, to build the container image, to deploy it and run it on, on a Slurm scheduled machine, run some testing or benchmarks to see that, my code change to NPM hasn't made NPM itself, somehow worse. The automation of having that happen every single time you check code in is what I think is enabled. So it's a kind of a glue, it's a middleware that's enabling the use of the Slurm scheduler or the Slurm scheduled cluster in a more automated way. Does that help or make sense?
Yeah, no, that's very helpful. So yeah, thank you for that point of reference and just kind of explaining that. I need to keep in mind that this is all in the context of CI/CD. I found myself kind of thinking about other general jobs too.
Yeah, absolutely. And there's nothing to stop with CI/CD, if you wanted to, run the same kind of workflows, trigger the same kind of workflows from a graphical application, right? Like a science gateway or other contexts, like Nathan was alluding to, maybe you want to run a Slurm job every time, you get a bunch of data downloaded from your telescope, right? And that's the case of the NASA NUID project. Any kind of situation where you want to automatically run some code as a response to some action, and you don't want a human to have to be in the loop, every single time. Like the NUID telescope images drop at midnight every night, so we want to kick off that pipeline, right, without a human actually ever having to push a button. So anytime you want to do that, I think it's helpful. Yeah, there was a question too in the chat about if we could go over the Docker access token again. And I know Jennifer messaged some instructions. Did everyone did anyone need us to do that again?
I'm happy to share my screen and go through it again. If we get if we get a thumbs up, I'd be happy to go through it again. wants to see it one more time. Excellent. Let me share my screen. Going to this one here. Okay, so we are in Docker Hub. Let's just go back. Actually, let's sign out real quick. Start from the beginning. So at let's go back to the actual home page here. Hub.docker. Well, docker.com. Okay, so at hub.docker.com, we're going to hit the sign in button at the top right. Use your username and or email address to log in. So Nathan DF here, my password. Now I'm logged in. I'm going to go to the drop down at the top right of the page where my username is. I'm going to click it, and then I'm going to click account settings. So here we're going to see that there's a little sidebar below our profile, and we're going to click security. And when we click security, we are given the ability to create and delete our access tokens. So we're going to click the new access token button at the top right of the access token block here. Going to give it a description, and then make sure that it has read write at least. So one of these two options should be fine. Select it, and then hit the generate button. So we could do another one, and I hit generate, and now I have this personal access token. So I'm going to copy that. You can also hit the copy and close button. That'll be fine. And then back in the cell that requires your Docker Hub username and Docker Hub personal access token, you'll run that cell again. It'll prompt you for your username. You'll type that in, hit enter, and then it'll prompt you for the password. I should delete these. All right. There we go. So I will stop sharing. Does anybody else have any more questions, or did they run into any problems running their pipelines, or have any questions in general about Tapas, any of the APIs or workflows specifically? All right. Anagha, did you have anything that we needed to follow up with?
Yeah, so I was thinking, can we show them the Tapas UI and a way to show their systems and apps through the Tapas UI?
Sure. Let me get that ready.
Okay, thank you.
Uh-huh. Okay. I will share my screen. So this is just a bonus. I'm just gonna show you guys the Tapas UI. So this happens to be the actual deployment on the Tapas Kubernetes cluster, but this could very well be one of your GitHub pages that you launched with your own Tapas UI. But this is not tenant specific. This can access all tenants. So at tac.tapas.io, if you have, actually, why don't we do, let's do training.tapas.io. So we all have these credentials, which should work for the Tapas UI. So if you go to training.tapas.io, actually, let me just copy this. I'll copy this into the chat, and you guys can copy and paste it. It's really important for it to be exact, because the way single page applications works, you see we have this little hash here, and that basically tells the React router that everything that follows after this is going to be is going to be mapped to a particular route and to render certain components. So there's never a page reload in this React application, which is really nice. So let me find the Zoom here. Where is the chat? Technical difficulties. There it is. All right, I am posting the link. If you guys want to go to that, you can. And I'll just go through what is available through Tapas UI. So when you first get to training.tapas.io, you're going to be prompted to log in. You can hit the login button and you can provide a username and password. So I have this account, test user 2, and its password. And then I'm going to hit login. Uh-oh, we're in train. Oh,
Yeah, you have to
test
use
user
a,
2. There is no test user 2, huh?
Yeah.
So what was it? Gateways.
Yeah, let me put it in the chat. The one I
Thanks.
used. So, yeah.
So I was using the wrong credentials there.
Are you able to copy from the Zoom chat?
I don't see it in the Zoom chat.
Oh, okay, maybe I'll just.
It's, well, it's, and then it's gateways 23 dash
23,
training
yeah.
Dash
dash
training.
23. For example, 3 was the one I think we were
Okay.
Yeah,
using.
that's the one and same password.
Okay. Okay, so we're going to log in with our credentials here. And we can see that we have, here's the dashboard, and we can see that we have some of these high-level Tapas objects. So we have the systems that we created. It shows that we have files on 2 systems. We created 1 application, and there are 5 jobs that have been run. So this just gives you a high-level overview of all of your Tapas objects. In the system section, we can look at the files on the Tapas system. So I'm sorry, in the system section, we can look at the details of our system. So what is the system type? Who is the owner? What is the host, etc. All of the information is available here. And in the file section, we can choose which system we want to view the file system of. And so in the VM version of the system, you can see that we have, this is the root of the system. And so if we go into Workdir, we're going to see this jobs directory. We can navigate through these various different directories, and we can see all the jobs that were previously run. So what was the last job? 1025, 14, I guess. So we click that job UUID, and then we see here that we have the tapas job.sh. So that's actually going to be the actual script that was run by Tapas. And then we have the output directory, which is where our output files are stored. So again, we have the tapas job.sh because we specified that in our archive filter, and also the environment. And then we have the standard out of the job that was run, which was the npm job. And so if we wanted to view this, we could just click the checkbox and download it. Currently, there is no feature for like viewing it in the Tapas UI itself, but we do plan on adding that in the future. So it's pretty neat. You can view all the files on the system and then navigate through the all the subdirectories thereof. And then we look at applications. And we have one application here, and we can see, let me get rid of this chat here. We have this job launcher wizard. So this takes your application definition, takes your system definition, and all the job attributes, and it constructs a wizard that basically prompts you for everything that is required to submit the job, and also allows you to change things such as, you know, the max time on your batch scheduler, and we'll go through it here. So I hit continue, and by default, this application it requires an execution system. So we could say we're going to use that VM system, and since it's the VM and not the batch or the HPC system, we're going to use the job type of fork. You have the ability to add to specify that this is indeed an MPI job, and then you can use your MPI run or IB run command right here is where you would type here, MPI run, I believe, right? But this is absolutely not an MPI job, so we're not going to specify that. And you can modify some of the base directories of the system itself. So when we continue, here's where you specify where the file inputs are. So like the files that you want to be staged and to be processed by your job. So you can add file inputs, you can browse the file system and choose a file from a system. So that's pretty neat. And just skip through all the other, I guess it did require something here. For some reason, it's not letting me skip to the ends. I do believe there's a something that needs to be specified here. Anywho, having a little technical difficulty, but you can specify your file inputs. We can see that application arguments are also specified, and we're just pointing at a file that is actually inside of the container image already, and this job is just going to essentially run that file or file over that data. You can specify environment variables, scheduler options, archive systems, where to archive to, and at the end you hit the submit job, and it's going to create a job object which you can view in the job section. So here we can see that all the jobs that we've run have ended up in the finished state. So we have successfully run it. And just like you saw in the Jupyter Notebook, it's got all of the details of where to find, like where the job executed, where all the inputs were stored, where all the output ended up from the job run, and also which system it was archived to, and a little bit about the batch scheduler as well, the batch scheduler options. So everything that was, like Joe mentioned, we keep track of all of the attributes, all the properties that were used in a job submission so that you can reproduce this easily. And then of course we have the workflows section. Here you can view your groups and see the users within that group. We can see the archives if specified. There's identities, which are essentially a mapping of your identity in Tapas to an external identity, so like a GitHub or a Docker Hub identity. All this is a way for you to easily store credentials. So say I want to push my Docker Hub image. I want to push the image up to Docker Hub using certain credentials. You could create an identity with a username and personal access token and tie it to that pipeline and say, use this identity's credentials to access either, that GitHub repository or Docker Hub registry, what have you. There's pipelines, and we can see that we have a pipeline here. This is the pipeline that we created, and there are 3 tasks. So if we go in and look at those, we can see that we have the npm builds, which built our image, and then specify these other Tapas job tasks, show that we have dependencies specified, and they're of type Tapas job. And you can actually, you can see the pipeline runs. So when they were started, when they were last modified, you can view the task executions. As we can see, all the task executions were successful. And there's also this nice little breadcrumbs here that you can just navigate back. We can also run the pipeline. So for this group ID and this pipeline ID, we're going to run this pipeline. And that pipeline is now submitted again. That image is building, and then it's going to run the tests again. So a nice, easy interface for using things like these APIs. They are actually pretty complex if you really want to get into all the details. So, when you have this complexity and you're trying to manage these like really complex objects on the command line, it can be just a pain. It could be a big handful. So we developed this UI to make it easier for users They don't even necessarily have to have any knowledge of the command line. They just have an application, they want to run it, they have some data, they point it, they point their job to that file and say, hey, use this bit of data and press a button, run the application. It's a much nicer interface, and it doesn't require that users of Tapas be very technical at all. So that's one of the main driving forces behind the Tapas UI. And I see we have a couple of questions. I don't think anything related to the Tapas UI, but yep, that concludes my presentation of the Tapas UI. Joe or Steve, Anagha, do you guys have anything you want to add?
Oh, that was great, Nathan. Thank you so much. Yeah.
Absolutely.
I put in one of the comments on the chat. We're having some nice discussions in there. Thanks, everyone. If anyone would like to reach out to us, to learn anything more about this or other topics, you can feel free to email me directly. I put my email in the chat. It's just my name, jstubbs@tac.utexas.edu. So you can email me. We also have a Slack channel, or a Slack team, I should say, TAC Cloud, TAC-Cloud, and we can put a link to join that Slack team in the channel. Let me get that. So yeah, I mean, we would just in general love to hear from you all. If you have any thoughts or additional questions, or anything else you want to follow up on. Let's see if I can get this in there. Yeah, that join Tapas link I put in the channel, and that link you'll also find on the GitHub resources and stuff, the materials for the workshop today. So yeah, that's it for me. Awesome, everybody. Well, hey, thanks so much for your participation, for sticking with us to the end here. This really does conclude the Anagha, was there anything else you wanted to say?
No, I think this is pretty much it. It was really great interactive session. Thank you all for your attention today, and
yeah, absolutely.
input.